Let's talk about solving quadratic equations. There are actually 4 different ways that you can solve quadratic equations, and we'll look at the 2 that are considered to be shortcuts. First off, what is a quadratic equation? It is any equation whose exponent is 2. Now, the first shortcut method for solving an equation is to use factoring. We've covered how to factor polynomials before, and you will notice these polynomials have equations because there's an equal sign right here. Before you factor, always make sure that it is equal to 0. So 0 here is necessary. So if it's not, move everything over to the same side of the equals and make it equal to 0. On this first example A, I notice I have 3x squared minus 9x, and right off the bat, it jumps out at me that this is a greatest common factor, or GCF problem. If you notice, 3 will divide into both numbers, and it has x in common. So 3x would be my greatest common factor, my GCF. Now if I divide both these terms by 3x, remember factoring is just like dividing, then that will leave me x1 in the front of the parentheses, or in the first position, and then -3 times -9 times divided by +3 is -3, like that. And bring down the equal 0. Now it's factored. Take each part of the factor. So that means take the 3x that's in the front, set that equal to 0, and solve it. If I solve for x, I simply divide out the 3, and I get an answer of x equals 0. Then I will take the second factor, which is x minus 3, whatever you have in parentheses, and I will solve for x again. On this one, I need to move the -3 over and make it become a +3. Remember, when you move that term over, you're really adding and subtracting. You have to change the sign. So x is equal to +3. You will not just get one answer, but 2 answers with quadratic equations. That exponent of 2 from the fundamental theorem of algebra tells us that there are 2 solutions. Now, when we go to this second example, example B, it is not equal to 0. So the very first thing I'm going to do is move that 1 over and rewrite the original problem. The original problem then would be 2x squared plus x minus 1, because I moved that 1 over and it changed the sign. So this is a trinomial. Well, with any trinomial, I'm going to need 2 sets of parentheses. I'm going to go ahead and look at this one. Oh, this is a type 1 trinomial, and you can, let me go ahead and erase what I had written, because with a type 2 trinomial, now remember, type 2 trinomial has a number in front of the x squared. We had covered the grouping method for type 2 trinomials. So if I take the 2, multiply by the -1, that gives me a -2. What are the factors of -2? That would be -1 times +2. Why did I make the 2 positive and the 1 negative? If you recall the sign rules for this, the larger number, when you're using different signs, the larger number has to go with the middle term. Why did I use different signs? Well, it ended up when I multiplied those, I had a negative. And anytime you have a negative with a trinomial situation, use different signs. So I'm going to rewrite this problem. I'll bring down the original 2x squared, but instead of x in the middle, I'm going to rewrite this as -1x and +2x. I get that from my -1 and my +2. Then I bring down my -1. This is now a grouping problem, so I draw a line down the middle and take the GCF in the front. The greatest common factor, GCF in the front, is x. So I will divide out an x in both the front 2 terms. That will leave me 2x and a 1, a negative 1. Now in the back terms, the two terms directly behind the line, there is nothing in common. So I will just put a plus 1 like a placeholder and use that as my GCF. And if I divide by 1, I'll still just get 2x minus 1, just like that. Now with grouping, we know the 2x minus 1, those are the same. So I bring that in front. And then I have x plus 1 equals 0. Now, what I need to do is take each one of these factors and set it equal to 0. Now, I've almost run out of room here, so let me go ahead and make a little room. Let me take this 2x minus 1, set it equal to 0, draw myself a box so that you can tell what goes with what. I'm going to move that 1 over, becomes positive, and divide by 2. Aha! One of the answers for the part B example is 1/2. Now I'm going to take this second factor, move it to where I still have some room on my paper, draw myself a box so you can tell what goes where, move that 1 over, and it would be negative 1. So the two answers for this second example would be 1/2 and negative 1. The second method on solving a quadratic equation is really one of my favorites. It's the square root method. To me, it just seems to be pretty direct. And again, it's one of the shorter ways that you can solve a quadratic equation. For it to work, though, you must have something that is a perfect square. And I use perfect in parentheses here because as long as we can just put the radical sign and the square root on it, we're good to go. For this to work, you need to isolate the perfect square. Now, in my first example, the only thing that's the perfect square is x squared itself. So I'm going to try to isolate that. What I can do is move over my negative 21 and it becomes a positive 21. Then, to isolate the x squared, I'm going to divide by 3. It's a lot like solving for an x. Now, even though 7 is not a perfect square, what you can do is put the square root radical symbol over both sides. As long as you do that to both sides, you're still good. The square root of a perfect square are inverses. They cancel each other out, leaving x. Now 7 is not a perfect square and cannot be simplified any further by hand, so we will leave square root 7. Now remember just a second ago I told you you should get two answers because it's a quadratic equation, exponent of 2. The way we get the two answers is we put a plus and a minus symbol right here. That stands for positive and negatives. So my answer is a plus minus square root 7. Some people prefer to write that out as the two separate answers, showing a positive square root of 7 and a negative square root of 7. You may write that either way. Now in example B, notice that my x is inside of a parentheses, but it does have a square on the outside. As long as you have something perfectly square that's isolated, you can start. So I'll go with putting a square root symbol on both sides. The square root and the square cancel out, leaving x plus 5. You may drop the parentheses now, and that is the square root of 11. But again, notice, I only have one square root of 11. Right here is where I'm going to put that plus minus. Make a note. Use the plus minus symbol as soon as you take the square of both sides. So don't wait to the end of the problem or you'll get the wrong answer. Put that plus minus in right there. Now to solve this, I can simply move the 5 over with square root 11. and I will get a negative 5 plus minus square root 11. You may stop right there and record that as your answer. That does indicate two answers. However, if you want to separate it, you could put negative 5 plus square root of 11 and negative 5 minus square root of 11. We cannot simplify any further because 11's not a perfect square.